Let's consider this given differential equation and find out if this is an exact or a non-exact DE. Now, let's try to first give the general form in determining whether this is an exact or not. We will have here m of xy dx plus n of xy dy equal to 0. With this, we can now say that m of xy is the function paired with dx, and that's actually x squared minus y squared. For our n of xy, this is actually the function paired with dy, this here, so that would be x squared minus 2xy. Okay, now that we are done determining the functions, let's try to show whether the partial derivative of m with respect to y is equal to the partial derivative of n with respect to x. And if we can establish this, this is enough for us to say that this equation is an exact differential equation. But if it's not, then this is non-exact. This is very essential because if we pertains on solving this differential equation, there are two different methods for exact differential equation and non-exact differential equation. Let's start with the partial derivative of m with respect to y. We are going to actually use y as our dependent variable. That would mean that for our function that contains x, we'll be treating that as our constant. In short, x squared here will no longer be a variable x squared or a term x squared, but it would be considered as a constant. In short, if we take its derivative with respect to y, that constant will become equal to 0. Okay? Now, similarly, the minus y squared will become minus 2y as we actually use the first order derivative as we take again y as our independent variable here. Okay? So, with that, our partial derivative is minus 2y. Okay? Now, for our first order derivative or partial derivative of n with respect to x, being x as our independent variable, this would be equal to, again, we are gonna take y, this y here, as a constant. So we will have, we can write this as x squared minus 2yx, as this is our new numerical coefficient as we take y as a constant for this given function, as we try to take its partial derivative with respect to the independent variable x. Okay? So with this, of course, this can be, since this contains x, that would actually be 2x. And then, as we take the derivative of our second term, of course, that's minus. Again, we're taking this as a constant, and as we take the derivative of that we have here our x. Of course, that's 1 minus 1. So you will have minus 2y, or we have 2x minus 2y. We can see here that the partial derivative of m with respect to y, our independent variable in this case, is equal to, or is not equal to, the partial derivative of n with respect to our independent variable x, as this is actually 2x minus 2y, and the other side is minus 2y. Again, with this means that our given differential equation is not an exact differential equation. With this, we'll be using a different method in solving for this equation, and that will be on a separate video. Thank you very much for watching.